Hi, today we discuss about this inverse kinematics. In forward kinematics, whatever we have done, whatever we have found out, but reversely, whatever we will find out now, that is called inverse kinematics. And in the let's start. What is it? Actually, forward kinematics we have seen before. We have denoted and theta 1 to d 1 to find out this way. And now in inverse kinematics, and given the in-factor is given location, find the joint variable. That means if is any buyer or any person want to measure this in-factor will be this, but how much joint will be there, how much length will be there, you have to find out. That means inversely we have to go. If you watch my previous video, you will get this answer. Okay, next one, that means in the basic assumption is actually, if I say in truly, is the difficult than the forward kinematics. And the basics assumes, we have to assume there's a three joint and also the in-factor, and next three joint determine the orientation. We have to assume an end-effector, and manipulator has extract the sixth joint. The second three joint make the spherical wrist. Okay, we'll more clear in next slide. And the equation will be xyz. Okay, here my sir has taught me, just I will deliver this, I will presentation this for understanding more clarification, nothing else. Let's start. This is the Cartesian manipulator. All are the prismatic joint, so we can say the Cartesian manipulators. We have to imagine. We have to stand the scenario in our mind. We have to good experience about the views. If we look in the front side for this object, in rectangular object, what we can see is normally we think this is the x1, y1, and z1 is going to how much thickness. We cannot watch that z1. So we draw this on and x1 and y1. Okay, and then after displacing this, what will be the scenario? And then we can also have to remember the system of the to identify or denoting system in coordinate system, and this on is displacing on z axis according to z axis, so we have denoted the z axis. And imagination in a second, that means a two coordinate system in displacing in the this way. That means that one is the z, and if it's z, and this z will go through that. That means y will be horizontally, y will be the vertically, and z will be in diagonally. And then why we give in that direction? Because this is the going in this diagonally, this object. And then we cannot see this one, we cannot see x2, just we can see that y2 and z2. Here we can say 0, 0.2 and that 1 to 2 point in the z2 and y2. Got it? And next one is the 3 in coordinate system. Also d is the displacement or distance, and coordinate system 3 we can see over here, and only the y3, that means this y3, and z3, that means this z3. We cannot watch this, because this is the thickness of that. In top view we cannot, sorry, in front view we cannot get this y3. And next one is the just the replica of that, I will get that. And also denote that the a1 is the link length, a2 also, and a2 and a1 is the same length. That's why we cannot denote. And a3 and d2 is the variable distance, and a3 is the fixed link length. That means a3 is the link length. And also d3, because this array can move displacement, sorry, can move displacement. Also d3 and a4 is the this direction will go. Okay, its total link length a4 plus d3. a4, that means this one is the a4, this is the a4 plus d3 total. When we observe on front view, okay, and then d1 is will get with 4 with respect to 0, x, y and z, and also the link length for a1, a2 and a3. And for also d2, that mean actually d is the variable. Again I am saying d is the variable, it's not fixed, it can change. That means displacement distance, and how much will this can ultimate condition can displace, because is the freely can displacement, but is real link length is a, but his displacement link length is the d. d2, from the d2 and d3 will get, because of that total is a3 and a2, d2, d3 and d1, d2 and d3 we get. And from that will, this is on just replace the position, we'll get the 4. Okay, and same way we have this figure. Also this one is the Cartesian manipulator, and on times, that means this one we have seen is the front view, and this one we have seen the top view, this one top view. And top view in the only one position we'll get, only one. For this reason is just we'll write down the total and we'll get this displacement. Oh, and inverse, and after getting that we have to set up, because it's V series or V very important to draw that axis is the main factor for this inverse kinematics, and set this one. That's when in 6 is with respect to 0. Use the forward kinematic ones first and 3 joint and calculate this and that way. And after all of the is the memorizing, just you memorize and put that what type of information or data we have got, just put down the theta and all are the same. For if you get the theta 4, just put and rotating to 3,3 and all are just put here, we'll get this. I think is so difficult in the last portion. If last portion is not clear, you can search in Google. I think 60 or 70% clear to you. Though you have confusion, you have to determine our paid courses as available in there. We'll clear. Thank you for your questioning, and for more query you can Google or search online. Thank you.